Welcome back, students and friends. After having gone through all the examples under the chapter Applications of Trigonometry, we are here to solve all the problems given in the exercise. And this is a very interesting exercise wherein we'll try to apply the basic fundamental principles of trigonometry to solve problems. You can also join the Telegram group. The link has been given in the description so that you get notifications of all the latest uploads of 10th mathematics. And also make sure that you also view all the videos of trigonometry. Now moving on with the first problem given in your exercise, which states that a circus artist is climbing a 20-meter long rope which is tied from a top of a vertical pole to the ground. So there is a pole here, AB, and then there is a rope which is tied to the ground. So this is the rope AC, and given the length of the rope is 20 meters. It's been given that the rope and the ground makes an angle 30 degrees. So we need to find the height of the pole, right? So this is the rope which is tied to the pole here, and it makes an angle 30 degrees, so I need to find AB. So this forms a right angle triangle, and we know that, let's apply sine 30. So what is sine 30? It is nothing but opposite side AB divided by the hypotenuse AC, right? So for easy reference, I've already written all the values here. Sine 30, 45, 60, and also for cos and tan, so that it becomes easier for us to apply. So I need to find AB. So AB is AC, which is 20, into sine 30 is 1 by 2, so I get 10 meters. So the height of the pole is 10 meters. So very simple problem. So moving on with the next one, a tree breaks and the broken part bends so that the top of the tree touches the ground, making an angle 30 degrees. So there's a tree here, okay, and the tree has broken. So let this be A and B. So the tree has broken such that it touches the ground at C. And it makes an angle 30 degrees. So we assume that the broken tree here is almost a straight line. So this is the tree which is broken, which has fallen to the ground. So this is a part of the tree and this is the broken part of the tree. So it makes an angle 30 degrees. Now what has been given? The distance between the foot to the top of the tree touching the ground is 8 meters. Okay, so therefore this is the foot of the tree and this is the top of the tree. So the tree was like this. Okay, so the tree has broken down and this is fallen. So when it breaks here, so the tree falls here with all the branches. So this is the foot of the tree and this is the top of the tree. Okay, and the distance between the foot and the top of the tree is 8. So this is 8 meters. So this is being given, BC has been given here, and this is how we need to analyze the problem. So now we need to find the total height of the tree. So what is the total height? The total height is AB plus AC, isn't it? Because the tree has broken down. So the total height of the tree is AB plus AC. So how do I do that? How do I find that? So first let's try to find AB here. So this is the opposite side and this is the adjacent side. So now let me use tan theta. So what is tan? This is theta, this is 30. So tan 30 is AB by BC. Right? So this implies, what is AB? AB is, so what is tan 30? 1 by root 3, and BC is 8. So this is 8 by root 3 meters. Okay? So after having done that, let us try to find AC. So now let me use cos 30. What is cos 30? It is adjacent side by hypotenuse. So which is BC by AC. So I need to find AC, which implies AC is BC. So we need to find AC, which is the hypotenuse. So AC is BC, which is 8 divided by cos 30. So what is cos 30? Root 3 by 2. So 2 goes on top, which is 16 by. So now what is the height of the tree? The height of the tree, so the height of the tree is it is nothing but AB plus AC, isn't it? So it is AB plus AC. And what is AB? AB is 8 by root 3 plus 16 by root 3. Right? So I get 24 by root 3. So this happens to be the height of the tree. Right? So in your textbook, what has been done is, they have written it as 24 can be written as 8 into 3, and 3 can be written as root 3 into root 3 divided by root 3. So 1 root 3 gets cancelled. So you have 8 root 3 meters. So that is the height of the tree, which is AB plus AC. The contractor plans to install 2 slides for children to play in the park. For children below 5 years, she prefers to have a slide whose top is at the height of 1.5 meters. So you know a slide, all of you must have played slide. Children love playing slides. Okay, so here for children below 5, you need to have a height of 1.5 meters and the inclination, so this happens to be the inclination, which is 30 degrees. Whereas for older children, right, so for older children I can have a height of 3 meters and the angle is 60 degrees. Okay, what should be the length of the slide in each case? So let this be ABC and let this be PQR. So what do children do? They climb up here and they sit and they slide down. So what is the length of this slide? So I need to find AC and I need to find PR. Okay, so again a very simple problem here. So we know that sine 30 is opposite side by hypotenuse. So we need to find the hypotenuse here. So opposite side is AB by AC. So I need to find AC. This implies AC is AB. AB is 1.5, isn't it? Divided by sine 30. Sine 30 is 1 by 2. So you have 3 meters. Okay, so the length of the slide here is 3 meters. So this is 3 meters. Next, again let me apply sine 60 here for the triangle PQR. So this is going to be PQ divided by PR. So I need to find PR. So this implies, what is PR? It is PQ, which is 3 divided by sine 60. It is root 3 by 2. Alright, so now I can write this 3 as root 3 into root 3 into 2 divided by root 3. So I get 2 root 3 meters. So this happens to be the length of the slide, which is 2 root 3 meters. So very interesting and a very simple problem here. So now let's move on to the next one. The angle of elevation of the top of the tower from the point of the ground is 30 meters away from the foot of the tower, which is 30 degrees. Find the height. So the angle of elevation. The angle of elevation of the top of the tower here, this is the, let this be the tower and let this be AB. Right? So from the point on the ground, which is 30 meters away, so this is the foot of the tower and this is C. So from a point which is 30 meters away from the foot of the tower, which is B, the angle of elevation is given as 30 degrees. So this is 30 degrees. So I need to find the height of the tower. So what is the height of the tower? The height of the tower can be given by, so we have tan 30. What is tan 30? Opposite side, which is AB, divided by adjacent side BC. So I need to find AB. So AB is BC, which is 30, into tan 30, which is 1 by root 3. So I can write this as 3 into 10 divided by root 3. All I can write is as root 3 into 10 divided by root 3. So I get 10 root 3 meters. So this is the height of the tower, which is 10 root 3 meters. Next problem. The kite is flying at a height of 60 meters above the ground. So 60 meters above the ground, you have a kite which is flying. So this is AB. A string is attached to the kite and is temporarily tied to a point on the ground. So this is the string which is attached to the ground C, and the angle of inclination is given as 60 degrees. So this is 60 degrees. So I need to find the length of the string. So I need to find AC. So this is the length of the string. Okay. So what do I do? So I have to use a relation which involves the opposite side by hypotenuse. Opposite side by hypotenuse is sine. So I have sine 60 equals opposite side AB by AC. So I need to find AC. So this implies AC equals AB. What is AB? 60 divided by sine 60. So sine 60 is root 3 by 2. So 2 goes on top. So again we can write 60 as 3 into 20 into 2 divided by root 3. So 3 can be written as root 3 into root 3. So one of them I cancel. So this is 40 root 3 meters. So this is the length of the string, which is 40 root 3 meters. So moving on with the next problem. Problem 6. So there is a tall boy of height 1.5 meters, right? So his height is 1.5. So let me draw the diagram here. So 1.5 meters is his height. He is standing at a distance from a 30-meter tall building. So here is a building. This is the ground. And the height of the building is 30 meters. Okay? Right. The angle of elevation from his eyes to the top of the building increases from 30 to 60 as he walks towards the building. If I draw a line parallel to the ground, the angle of elevation from his eyes to the top of the tower, so this is the top of the tower, is initially 30 degrees. Now he moves. So he is walking. Now as he walks, after a certain distance, the angle of elevation becomes 60 degrees. Find the distance he has walked towards the building. Okay, so let this be A, B, C, D, and then let this be E and let this be F. Alright, now the height of the boy is 1.5 meters, right? So here, that also includes the height of the building, which is 30. So therefore, if this is A, B and this is C, right, this point is C here, BC is 30 minus 1.5. So this BC is 28.5 meters. Alright, so now I would like to find this distance DE. So how do I find this distance DE? So now if I employ this, so here tan 30, so I have tan 30, which is the opposite side BC, divided by the adjacent side DE. So I have to use tan 30 degrees. So if I use tan 30 degrees, which is BC, divided by, this is AB, which is nothing but DE, isn't it? Alright, so here I am considering this right angle triangle ABC, but AB is equal to DE. Right, so I can find out the length DE. So what is DE? DE is BC, which is 28.5, divided by tan 30. So what is tan 30? It is 1 by root 3, so root 3 comes on top. So it is 5 into root 3 meters. So now let's find out EF. So I actually need to find DE because this is the distance which the boy has walked. So now let's consider the right angle triangle. So this right angle triangle here. So what is tan 60? Tan 60 is again BC divided by EF. So which implies, what is EF? EF is BC, which is again 28.5, divided by tan 60. What is tan 60? It is just root 3. Okay, so this is, so now what do I need to find? I actually need to find DF. So DF is DE minus FE. Alright, so DE is 28.5 root 3 minus 28.5 divided by root 3. So this is what I need to find. So now if I take the LCM, root 3, so this is 28.5 into 3, right? So I get 28.5 into 3 minus 28.5 divided by root 3. This is what I get here. Alright, so now I can actually take root 3 common outside. So root 3 is common outside here. So I can take 28.5 divided by root 3 into 3 minus 1. Okay, so I get 2 into 28.5. So this becomes 57 divided by root 3. Alright, so now I can write this as 19 into 3 divided by root 3, or 19 into root 3 into root 3 divided by root 3. So root 3 cancel, so I get 19 root 3 meters. Okay, so what is the distance which the boy walks? The boy walks a distance of 19 root 3 meters. So you have to remember this. The only thing what you need to remember is, using the first right angle triangle, I calculate the distance from where the boy is standing up to here, the building, and then he walks. And then again using tan 60, I find the distance of the boy from the building, but I need to find this distance, the distance which the boy has walked, which is DE minus FE. So when I do that, I get 19 root 3 meters. So problem 7, from a point on the ground, the angle of elevation of top and bottom of a transmission tower fixed on top of a 20-meter high building are 45 and 60 degrees respectively. So what is being given? So there is a building of height 20 meters, right? So on top of this, there is a transmission tower. So this is a transmission tower. Okay, so let this be BCA. So from a point on the ground, which is A, the angle of elevation to the bottom of the transmission tower is 45 degrees. And to the top of the transmission tower is 60 degrees. So this is the transmission tower. So we need to find the height of the tower. So I need to find this height of the tower, which is DC is what I need to find. So now, what is tan 45 degrees? So tan 45 degrees is opposite side divided by adjacent side. So what is opposite side divided by adjacent side? You have BC divided by AB. So I can calculate AB. AB is, BC is 20 divided by tan 45 is 1. So this is 20 meters. Okay, so this distance is also 20 meters. So the distance of the point from this tower is also 20 meters. Okay, so now let us apply tan 60, which is the whole length BD divided by AB. So I can find out what is BD. BD is tan 60. What is tan 60? It is root 3 into AB, which is 20 meters. So I need to find DC. So what is DC? It is BD minus this entire length minus this distance BC. Right, so it is 20 into root 3 minus 20. So this is the distance which I need to find. So I can take 20 common, root 3 minus 1 meters. So 20 into root 3 minus 1 meters is the height of this tower which is present on top of a building. Next, problem 8. The statue, which is 1.6 meters tall, stands on top of a pedestal. So there is a pedestal, right? So on top of this, there is a statue. The height of the statue is 1.6 meters. So this is the height of the statue. And from a point on the ground, so this is a point on the ground. So let this be A, and let this be B. The elevation of the top of the statue is 60 degrees. The angle of elevation to the top of the statue is 60 degrees. And from the same point, the angle of elevation of the top of the pedestal, so this is the pedestal, the top of the pedestal is 45 degrees. So I need to find the height of the pedestal. So I need to find this. So let this be C and D. So I need to find BC. So you observe that these two problems are almost the same, isn't it? Alright. So now let's find tan 45. So what is tan 45? It is BC divided by AB, right? Or we come to the conclusion that AB equals BC. So the height of the pedestal and the distance AB is the same. So if this is x, this also is x. So this is what we come to the conclusion. So let this be x. Alright. So now tan 60. So what is tan 60? It is the opposite side, which is BD divided by AB. Now what is tan 60? Tan 60 is root 3. So I have root 3 into AB is x equals, what is BD? BD is 1.6 plus x, isn't it? So I have an equation here. So I have root 3x equals 1.6x. So I can bring this x to LHS. So I get x into root 3 minus 1 equals 1.6, or x equals 1.6 divided by root 3 minus 1. So this is what I get, the value of x. So now we actually need to find the value of x, where x happens to be the height of the pedestal. So what do? I rationalize this by multiplying and dividing by root 3 plus 1. So this is of the form a minus b into a plus b. So a minus b into a plus b is a square minus b square. So what is a square? It is 3 minus b square is 1. So here I get 3 minus 1, which is 2. Alright. So I get 1.6 divided by 2 into root 3 plus 1, or it is 0.8 into root 3 plus 1 meters. So this happens to be the height of the pedestal BC. So BC is 0.8 into root 3 plus 1 meters. Then the next problem, the angle of elevation of the top of a building from the foot of a tower is 30 meters. So here there is a building and we have a tower. This is the ground. It's been given that the angle of elevation of the top of the building from the foot of the tower is 30. So let this be building and let this be the tower. Okay, so from the foot of the tower to the top of the building, it is 30, whereas the angle of elevation of the top of the tower from the foot of the building is 60. So from the foot of the building to the top of this tower is 60. If the height of the tower is 50 meters, so this is 50, then I need to find the height of the building. Alright, so now let this be A, B, C and D. Alright, so now let us try to find. So now let me apply tan 60. So what is tan 60? If I consider this triangle ADB, right angle triangle, tan 60 is nothing but AB divided by BD. So which is AB divided by BD. So this implies, what is AB? AB is 50. And what is BD? BD is AB divided by tan 60. What is tan 60? Root 3. So BD is 50 divided by root 3 meters. Okay, so this is the distance between the building and the tower. So now let me apply tan 30. So what is tan 30? Opposite side, which is CD divided by BD. So I need to find the height of the building, which is CD. So this implies CD equals BD, which is 50 divided by root 3 into tan 30. What is tan 30? 1 by root 3. So I have 50 divided by 3 meters. Okay, so now the height of the building is 50 divided by 3 meters, or it is, if you divide, you get 16 2 by 3 meters. So problem 10 is a very interesting problem. So there are two poles of equal height which are on either sides of a road. The width of the road is 80 meters. Alright, so let this be AB and let this be CT. From a point on the road, so let's consider a point on the road. Let this point be E. The angle of elevation of the top of the poles are 60 and 30 degrees respectively. So therefore, so this is the angle of elevation. Okay, so one of them is 60 and the other one is 30. Of course, the point which is closer to the pole, the angle of elevation will be 60, whereas the point which is further away from the pole, the angle of elevation will be 30 degrees. So we want to find the height of the poles as well as the distance of the point to the poles. So we need to find both of them. So let's assume that the height of the poles be x, right? And this, let this be y, and therefore this will be 80 minus y. So here you have dE equal to y. So now let me apply tan. So what is tan? Let me consider the right angle triangle CDE. So tan 60 is opposite side, which is CD, which is x. So I'll directly write x divided by the adjacent side ED, which is y. Whereas tan 30 is, what do I get? I get x divided by BE, which is 80 minus y. Alright, so from this I get x equals y into tan 60. What is tan 60? Root 3. So it is y into tan 60 is root 3. So x equals y into root 3. Whereas from this, what do I get? I get x equals tan 30 is 1 by root 3 into 80 minus y. Okay, so here I have x equals y into root 3, which is equation 1. And again here I have x equals 80 minus y divided by root 3, which is equation 2. So if I consider equation 1 and 2, LHS is the same, which is x. So I can equate the RHS. So equating the RHS of equation 1 and 2, I have y root 3 equals 80 minus y divided by root 3. Take this root 3 to LHS. What do you get? You get 3y equals 80 minus y. Bring this y here, I get 4y equals 80, which implies y equals 80 by 4. What is 80 by 4? It is 20. So y is 20, that means it is 20 meters. So this is 20 meters. So y is 20 meters here. And this is 80 minus y, which is 80 minus 20, which is 60 meters. So the point E is at a distance of 20 meters from the pole, and again is at a distance of 60 meters from the pole. Now we also need to find x, which is the height of the pole. So what is x? It is y into root 3. So the height of the pole, which is x, is y, which is 20 into root 3 meters. So this is 20 into root 3 meters. And of course this also is 20 into root 3. So we have found out the height of these two poles as well as the distance of the point from these two poles, which is 20 and 60 meters. Problem 11. A TV tower stands vertically on a bank of a canal. So this is a TV tower. From a point on the other bank, so there's a canal here. So from a point on the other bank, which is opposite the tower, the angle of elevation to the top is 60 degrees. So the angle of elevation is 60 degrees. Alright, so let this be A, B and C. From other point 20 meters away, so I move 20 meters away, let this point be D. On the line joining the point to the foot of the tower, the angle of elevation to the top of the tower is 30 degrees. So this is 30 degrees. So from a point on the other side of the canal it is 60. So from here I move 20 meters. And from this point again the angle of elevation is 30 degrees. So I need to find the height of the tower as well as the width of the canal. So let this be h, the height, and let this be x, which is the width of the canal. Me apply tan 60. So tan 60 is opposite side by adjacent side. So let me write h by x directly. Apply tan 30. So tan 30, if I consider this triangle ADB, tan 30 is opposite side, which is AB, is h, divided by the adjacent side, which is x plus 20. Alright, so now this can be written as h equals x into tan 60. So h equals x into, what is tan 60? Root 3. And similarly here, h equals tan 30. What is tan 30? 1 by root 3 into x plus 20. So h equals tan 30 into x plus 20. So again, if I observe these two equations, 1 and 2, LHS are the same, so I can equate the RHS. So I have x root 3 equals 1 by root 3 into x plus 20. So take this root 3 to the other side, so I get 3x equals x plus 20. Or if I bring this x to LHS, 3x minus x is 2x equals 20, or x equals 20 by 2, which is 10 meters. So x is 10 meters. So what is the width of the canal? The width of the canal now is 10 meters. And I also need to find the height. What is the height? The height is given by h equals x into root 3. 10 into root 3 meters. So problem 12. From a top of a building which is 7 meter high. So there's a building here of height 7 meters. So let me call this as AB. The angle of elevation of the top of a cable tower is 60. So there is a tower. Okay. So let this tower, so let this be A, B, C, and let this point be D and E. So this is a tower, CE is the tower. So the angle of elevation of a cable tower is 60. So from the top of the building, the angle of elevation is 60 degrees. And the angle of depression to its foot is 45 degrees. So from here, the angle of depression is 45 degrees. So we need to find the height of the tower. So this is 7. So since I've drawn a line parallel to the ground, BC, this also is 7 meters. I need to find the height of the tower, which is EC, so I need to find DE. Now, from this is 45, this also is 45, because this angle is 90 degrees, this is 90, and we know that sum of all the angles of a triangle, the internal angles is 180 degrees. So this is 90, this is 45, this also has to be 45 degrees. Now this is 45, this also is 45, and of course this is 90. Very simple. So now let us apply tan 45 degrees. So what is tan 45 degrees? Tan 45 degrees here, considering the triangle ACD, and considering this angle. Okay, so tan 45 is the opposite side, which is CD, divided by the adjacent side AD. So here we have CD equals AD, because tan 45 degrees is 1. So CD equals AD, but we know that CD is 7, so AD is also 7. So AD is the distance between these two, so this also is 7 meters. Okay, so this is 7, AD is 7. So now let me consider the right angle triangle ADE. So triangle ADE. So what is tan 60 here? It is opposite side, which is ED, divided by the adjacent side AD. What is AD? AD is 7. So ED is tan 60. What is tan 60? It is root 3 into 7 meters. Alright, so I need to find the entire height of the tower. So the entire height of the tower is nothing but EC. So EC is ED plus CD. So ED is root 3 into 7 plus 7. So I can take 7 common, it's root 3 plus 1 meters. So it's 7 into root 3 plus 1 meters is the entire height, EC. Next, moving on, the 13th problem. So observe from the top of a 75-meter high lighthouse, from the sea level, the angles of depression of two ships is 30 as well as 45 degrees. If one ship is exactly behind the other on the same line of the lighthouse, we need to find the distance of those two ships. So here, what has been given? It's been given that the height of the lighthouse is 75 meters. Okay, so let this be AB. Alright, so now there are two ships. At one point C there is a ship, at the other point D there is a ship. Now what else has been given? It's been given that the angles of depression of the ships are 30 degrees as well as 45 degrees. Alright, so if I consider a line parallel to the ground, the angle of depression here, so if I join AD, so this is 30 degrees, and if I join AC here, so you need to have the angle here, so the angle of depression here is 45 degrees. So these are the two ships, and we need to find the distance between these two ships. Alright, so now let this point be E. So we know that angle EAD is equal to angle ADB. So this also will be 30 degrees. And angle EAC will be equal to angle ACB, that is known. So therefore this also will be 45 degrees. So here angle C is 45 degrees. So now let me consider this right angle triangle ABC. So considering this right angle triangle ABC, and here tan 45. So what is tan 45? If I consider this angle, it is opposite side, which is AB, divided by adjacent side BC. Okay. Now AB is 75 and BC we need to find. Tan 45 is 1. So what is BC? BC is also 75 degrees. So this implies that BC is 75 meters. So now let's come here. So what about this? So let me apply tan 30. So tan 30 is again AB divided by BD. So this implies, what is AB? AB is 75, isn't it? So I need to find BD. BD equals AB, which is 75, divided by tan 30. What is tan 30? 1 by root 3, or it is 75 into root 3 meters. So here therefore BD is 75 divided by 1 by root 3, which is 75 into root 3 meters. So BD is 75 root 3 and BC is 75. I need to find CD. So BD is known, which is 75 root 3 meters. I need to find CD. So what is CD? It is BD minus BC. So it is 75 root 3 minus 75. So what do I get? I can take 75 common. So if I take 75 common here, I get 75 into root 3 minus 1 meters. So the distance between the two ships is 75 into root 3 minus 1 meters. So the next problem is very interesting. So there's a girl of height 1.2 meters and she spots a balloon. So let this be the ground at a height of 88.2 meters. Okay, so this is her height, which is 1.2. So the angle of elevation from her eyes is 60, right? So she spots a balloon here. So this is 60. So let this be C, let this be A, and let this be B. So the height is 1.2, her height is 1.2. So therefore what is BC? It is 88.2 minus 1.2. So this is 87 meters. Okay, because she is seeing here. So from the top, that is, she is viewing the elevation from her eyes is 60, isn't it? Right? So from here, from point A, the angle of elevation is 60 degrees. So I need to subtract 1.2 from 88.2 to get 87. Now after some time, the balloon has moved and it is now at point E, and now we find that the angle of elevation from our eyes is 30 degrees, and of course the height remains the same. Okay, so let me call this as point D. So now the question is, what is the distance traveled by the balloon? So the distance traveled by the balloon is from C to E, which is equal to B to D, whereas the height has remained the same. So now let me consider the right angle triangle ABC. Alright, so for the angle ABC, I have tan 60 is BC divided by AB. So what is BC? BC is 87. So this implies AB is BC, which is 87 divided by tan 60. So what is tan 60? It is by root 3 meters. Okay, so therefore we find that AB is 87 by root 3 meters. So now let me use this right angle triangle AED. So now what is tan 30? So tan 30 is ED divided by this entire length AD, which implies, so what is ED? ED again is 87, isn't it? So it is again 87, so I need to find AD. ED is 87 divided by tan 30 is 1 by root 3, so it is 1 by root 3, which is 87 root 3 meters. Okay, so AD is 87 root 3, and I find that AB is 87 by root 3. So I need to find BD. So what is BD? BD is this entire length AD minus AB. So which is 87 into root 3 minus 87 by root. So now if I take the LCM here, so I get 87 into 3 minus 87 divided by root 3. Okay, so you can do the calculations. So you get 87 into 3 is, so let me write it here. So let me write this here. So 87 into 3 is nothing but 261 minus 87 divided by root 3. So what do I get? I get 174 divided by root 3. Okay, so now if I write this as 3 into something, okay, so this can be written as, so isn't it? So 58 into 3 is root 3. So how did I get 58? If I divide 174 by 3, I get 58. So now this can be written as 58 into root 3 divided by root 3. So root 3 gets cancelled. So I am left with 58 into root 3 meters. So what is the distance traveled? The distance traveled by the balloon is 58 into root 3 meters. So this is the distance traveled by the balloon. So here there is a tower. Now let me read the problem. A straight highway leads to the foot of a tower. So there is a highway which leads to a foot of the tower. So this is the tower AB. So this is the tower. So let the height of the tower be x. A man standing on top of a tower observes a car. So he is observing a car. A car is here. Okay, let this point be C. And the angle of depression is 30 degrees. So here the angle of depression. So here the angle of depression is 30 degrees. So if this is 30 degrees, this also is 30 degrees. Now the car is approaching. The car is moving from point C towards the tower with a uniform speed. Uniform speed meaning constant speed. So 6 seconds later he finds the car here at a point say D, where the angle of elevation, he finds the point. Now after some time, that is after 6 seconds, the car has moved from point C to point D. So it has taken 6 seconds. and the angle of depression is now 60 degrees. So if this is 60, then this also is 60. So now the question is, find the time taken by the car to reach the foot of the tower from this point, right? So therefore, what is the time taken for the car to reach the foot? So how much time will it reach? Point B is the question. Alright, so now we know that the car is moving at a uniform speed, right? So now let me consider tan 60. So by considering the triangle ABD, tan 60 is AB by BD. So this implies that tan 60, what is tan 60? Root 3 into BD. BD is not known. Okay, so let me call this distance as y. Alright, so BD is y equals AB is x. Okay, so x equals root 3 into y. So now let me consider tan 30. So what is tan 30? It is nothing but the opposite side, which is AB, which is x, divided by, this is y, which is BD, and here I have CD. So CD is also not known. So let me write it as BC. So tan 30 is AB, which is x, divided by BC. Now what is BC? It is BD plus CD. So it is y plus CD. Alright. So therefore, this can be written as x equals tan 30 is 1 by root 3. 1 by root 3 into y plus CD. Alright. So now I have x equals root 3 into y, and x equals y plus CD divided by root 3. So now x is root 3 into y, x is also equal to y plus CD by root 3. So I equate both of them. Root 3y equals y plus CD divided by root 3. So this root 3 goes to LHS, it becomes 3y equals y plus CD, or this implies 2y equals CD, or y equals CD divided by 2. Okay, so this y is CD divided by 2. So this is half the distance. Okay, right? So this is half the distance. Y is this distance divided by 2. Or if this is y, this is 2y. So the car takes 6 seconds to travel a distance to y. Since it is moving at a uniform speed, the car will definitely take 3 seconds here, because this is half the distance. So therefore the car takes 3 seconds to reach the bottom of the tower, that is to travel a distance BD. It takes 3 seconds to reach the bottom of the tower. Okay, since BD is half of CD. So that's the conclusion what we make. A very interesting problem. So let's move on with the next problem. The angle of elevation of the top of the tower from 2 points at a distance 4 meters and 9 meters from the base of the tower and in the same straight line with it are complementary. Prove that the height of the tower is 6 meters. So this is the problem here. So we have the tower, which is AB, and there are 2 points, the point BC and D. Okay, right. So now what is being given here? It's been given that the distance BC is 4 meters and the distance here BD is 9 meters. So now we need to prove that the height of the tower is 6 meters. Now let's assume that this angle is x. Now this is 90 degrees. Alright, so this is x, this definitely is 90 minus x. Alright, so if this is 90 minus x, then what should be this angle is the question. Okay, so this angle also will be 90 minus x. Now this is so because it has been mentioned that the base of the tower where the points C and D are in the same straight line, the angles are complementary, right? So if this is x, this is 90 minus x. So what is tan x? So tan x is AB divided by BC, and therefore what is AB? AB is BC. BC is 4 into tan x. Okay, BC is 4. That's what is given here. So let me call this as equation 1. Now I have tan 90 minus x. Alright, so tan 90 minus x is again by considering the triangle ABD. Tan 90 minus x is AB divided by BD. So here I get cot x into BD. What is BD? Is 9, and this is equal to AB. Okay, so I have one equation where AB equals 4 tan x and AB equals 9 cot x. So this is equation 2. So I have equation 1 and equation 2. I need to find AB. So for that, let me multiply equation 1 and 2. So on the LHS, so I can write this as AB equals 9 cot x. So why am I doing it? If I multiply both the LHS, it becomes AB square. And if I multiply both the RHS, tan x and cot x gets cancelled. So I get 4 into 9, which is 36. And what is AB? AB is plus or minus root 36, which is plus minus 6. Okay. So now the height of the tower cannot be negative. So therefore, this height is 6 meters. So AB equals 6 meters. So we have proved that the height of the tower is 6 meters. Okay, so with this we have completed all the problems given in the exercise for applications of trigonometry. You have observed that some of the problems are very interesting, especially the last few problems where we really need to think and apply the basic fundamental principles of trigonometry. Okay, so it is not just enough if we know what these values are, what is sine, 30, 45, 60 and so on. We also need to know how we can apply and understand the angle of elevation as well as angle of depression and analyze the problem and write it in a pictorial form. Right? So it is very important for us to visualize the problem, write the right diagram, and once the diagram is written correctly, then solving the problem becomes very easy. Okay, so make sure that you practice all the problems again and again so that it becomes easier for you to solve the problems given in the examination. Now make sure that you go through all the videos and solve problems, and do not forget to like, share and subscribe and press the bell icon to get notifications of further uploads. And also there's a Telegram link which has been given in the description. Make sure that you join so that you get all the further notifications of all the uploads of 10th mathematics.